Chapter 5.6, Maps and Scale Drawings. We are on page 213 today, and today your vocabulary words are scale drawing and scale. Now, a scale drawing is something that is enlarged or reduced. It's a drawing that either makes an object bigger or smaller, but keeps it in proportion. The scale is the ratio that compares the length in a drawing or model to the corresponding length in the actual object. So for example, if I have 1 inch in a drawing, that can represent 15 feet in the actual object. Scales can be written 3 ways, using a colon, as a fraction, or as an equal sign. You will see them all 3 ways. However, the drawing goes first and the actual goes second. Or if it's a fraction, the drawing is in the numerator and the actual object is in the denominator. So how can we apply this? Let's take a look at example 1. On page 213, you're going to see a scale drawing of a house next to example 1 with the scale 1 centimeter equals 2.5 meters. The length of the side of a house, is 3 centimeters on a scale drawing. What is the actual length of the side of the house? So I'm going to set up a proportion. So my scale is that 1 centimeter equals 2.5 meters. On my drawing, however, the length is 3 meters, so what then is the actual length of the house? So I'm going to cross multiply. So x equals 3 times 2.5. So x equals 7.5 meters. Now these are word problems. Please make sure you do not forget your units. So notice in the example, the important thing is not necessarily solving it using cross proportions, but it's how you set it up. The drawing is in the numerator. The actual distance is in the denominator. I color-coded it also so that you can see that you're not having the drawing vertical, the drawing is horizontal, and the actual distance is in the denominator. Okay, example 2. Moving on to page 214. In the picture, there's a model of a boxcar, and that model is 7 inches long. It represents the actual boxcar, which is 609 inches long. So what is the scale to the model? A scale is similar to the unit rate. So in this, my model, 7 inches, represents the full 609 inches. But what would 1 inch represent? So here I'm going to have my drawing. Over my actual. So 7 inches over 609 inches. But I want to know, what does 1 inch equal? So I'm going to divide, and 7 divided by 609 is 1/287. So this is my actual scale. 1 inch in my drawing equals 87 inches on my actual boxcar. Example 3. I have a sailboat. It's 51 feet long and 48 feet high. I want to make a scale of my boat that is 17 inches wide. How tall is my boat? So I'm going to set this up with my actual boat and my model boat. So my model boat is 17 inches wide and some height. I don't know what it is. Not sure. My actual boat is 51 feet wide and 48 feet tall. So I have two options. I can use cross products, 17 times 48, 51x, and divide. Or I can simplify and use mental math, which is what I'm going to do here. So 17 51sts is the same as 1/3. Three to 16, I'm going to multiply by 60, or 3 to 48, excuse me, I'll multiply by 16. So 1 times 16, x equals 16, sorry, let's use the right units here, 16 inches. So the height of my model will be 16 inches. You can use cross products, that's totally fine with me, or you can reduce and use mental math. I'm okay with that too. Okay, last example, example 4. If you look on page 215, you're going to see a map. The map key says that 1/4 inch represents an actual distance of 5/8 of a mile. Find the actual distance represented by 1 inch. So I have my map and I have my actual. My map says that 1/4 inch is equal to 5/8 of a mile. I want to know what is 1 inch on a map. So if I cross multiply, 1/4 x equals 5/8, multiply by 4, x equals 5/2, or 2.5 miles. Okay, that's it. Quick checks and CYU, and we'll go over this next time I see you.